Okay, so the steps for graphing a rational function: number 1, find vertical asymptotes. Step number 2, find any non-vertical asymptotes. Step 3, find the y-intercept if there is one. There can't be a y-intercept if the line x equals 0 is a asymptote. Plot the x-intercepts. To plot the x-intercepts, you set the numerator equal to 0 and see what values make the numerator 0. We want to determine if it intersects the non-vertical asymptote by taking the original function and setting it equal to the value of the non-vertical asymptote. Then we're going to plot some random points, and then we'll sketch the graph. Okay. So, we've done some of these already, correct? So here's one, and this one's actually going to intersect the horizontal asymptote. So it's telling us this one actually has one, and we know that already. Can you tell me where the horizontal asymptote of this function is and why?
Oh.
It
A
is
second.
Okay, we have a horizontal asymptote located at y equals 3. Why?
Is it because it's the largest?
They're the same.
Oh,
So you
because
do
Okay.
X, oh.
So the degrees are the same.
what?
And then you do the coefficients of those 3/1.
Correct. The numerator has a degree 2. The denominator has degree 2. Because the degrees are the same, we look at the coefficients, or the leading coefficients, the leading term, which is 3/1. And 3 divided by 1 is 3. So we have a horizontal asymptote at y equals 3. Before we can talk about vertical asymptotes, we have to factor everything. Okay? So let's go ahead and factor the numerator. What's the first thing you always do in factoring?
Greatest common factor.
Greatest common factor, is there one?
Yes.
Okay, so the numerator, I will factor out a 3. That doesn't mean the 3 goes away, that just means I'm factoring it out. Taking a 3 out, I'm left with x squared minus x minus 2. All right, let's go ahead and stay with the numerator. Does that factor?
No.
Can you think of two numbers that would multiply
Oh,
together,
yes.
give you -2, but when you add them together, you get -1?
Yes.
You factor complexity.
What are those numbers? -2 and 1. So this factors into x minus 2 and x plus 1. So we have completely factored the numerator. How about the denominator?
No. Oh, 8.
Two numbers that multiply together to get 16,
Never mind.
but when you add them together, you get 8.
Positive 4.
4 and 4. So x plus 4, x plus 4, or we can be lazy and call that.
X plus 4 squared.
Okay, so we now have completely factored the numerator and the denominator. Does anything cancel? I don't have any terms in this top that are the same as the terms on the bottom, so nothing cancels. Okay? Vertical asymptotes. Vertical asymptotes means what values will make the denominator equal to 0. What would x have to be to make the denominator 0? -4. So x equals -4 is a vertical asymptote. Here's -4, here's a vertical asymptote. Okay. So I'll go back a slide real quick. Step number 1, find vertical asymptotes. Done, even though we did it second. Step number 2, find a horizontal or oblique. We've done that as well. Step number 3, y-intercept. Is there a y-intercept? Can x be 0? Yes, the only thing x can't be is -4. Okay, so to find the y-intercept, we want f of 0. When you plug 0 into the function, you have 3x squared, which is 0, minus 3x with the 0, -6 is on the top. Denominator, 0 plus 0 plus 16 is 16, and that reduces to -3/8. So my y-intercept is at the point 0, -3/8. 0, -3/8, almost -1/2. X-intercepts. So next, let's go back. Find the y-intercept if there are any. Done. Step 4, x-intercepts. How do you find x-intercepts?
Oh, wait. You equal the top to 0.
Top is 0. So x-intercept, or intercepts. I want the top. Now, I'm not going to use the original top. I'm going to use the factor top. So I have 3 times x minus 2 times x plus 1 equals 0. What values of x will make that 0?
3.
2 and 1, or -1.
2 and -1. So it's really, we could divide the 3 on both sides, right? And make the 3 just go away. Okay. So we have an x-intercept at 2. And we have an x-intercept at -1. So far, so good? Okay, let me go back a slide. We found the x-intercepts. Next, determine whether the graph will intersect the non-vertical asymptote. I have one non-vertical asymptote. My non-vertical asymptote is y equals 3. Is it possible for the function to equal 3?
Yes.
Okay. So, does graph touch the non-vertical asymptote? Is it possible for 3x squared minus 3x minus 6 divided by x squared plus 8x plus 16, is it possible for that to equal 3? The easiest way to do this is to make it look like a proportion. So I will put that 3 over a 1. Cross multiply. 3x squared minus 3x minus 6 times 1 is?
Squared minus 3x minus.
And x squared plus 8x plus 16 times 3?
3x squared
was 24x plus 48.
Okay. We need to solve this. Subtracting 3x squared from both sides makes the 3x squared just go away. I can now either add 3x to both sides or subtract 24x from both sides. I like to keep x positive, so I will add 3x to both sides. I have -6 equals 27x plus 48.
Or subtract
Subtract 48 from both sides.
-54.
I'm going to kick some people out of the class real quick. People that aren't taking notes, I'll kick them out of class. Okay. I'm not going to allow people to just sit and do screenshots. Okay, so this is -54 equals 27x. What's x? Divide both sides by 27. X equals
-2.
-2. Okay, what this tells me is this graph, when the x value is -2, it will touch the non-vertical asymptote when x is -2. Okay, so when x is -2, the non-vertical asymptote is up here at 3. So the point -2, 3 is actually on my graph. This graph either touches or goes through the horizontal asymptote at that point. I don't know if it just goes up and touches it and goes back down, or maybe it goes up. What do y'all think? Will it go back down?
No.
Why not?
Or even degree.
No, that's not the reason. Why will it not go down?
That's a question.
Oh, no, never mind, just kidding.
Just needed to make sure I shot.
Think about it, guys. Why will it not go back down?
It's a parabola. Just kidding.
It's definitely not a parabola.
Can I get a
Is that
hint?
only touches the point one,
It touches what
the
once?
horizontal asymptote?
Well, that could be a bounce. Right? Think about the quadratic y equals x squared. It only touches at the origin, but it bounces there, right? So what I'm asking you is, will this graph bounce at that point on the horizontal asymptote, or will it continue up forever?
I think it'll continue.
Why?
I don't know.
Shot in the dark. Well, it only has one
Cause
concave
it's not
exit.
gonna go.
There's no other place for it to enter or
Cause it's-
exit. It can only go through that one point.
Where, would say it again?
It can only go through that one point, right?
Well, at one point.
The point that's on the horizontal asymptote. So there's no entry, there's no exit except that one area.
Well, if it bounces, it only touches once. It can pass through or bounce, and that's only hitting you once.
Oh.
What's the purpose of that asymptote then?
Which one?
The horizontal?
Oh, it's got a purpose.
A bad
Can we get like?
I like the fact that this class kind of gives some thought to it. This class is very, very good about participating. I appreciate y'all. Okay, guys, I don't care if you're right or wrong. I want you to think about this. Does it pass through at that point on the horizontal asymptote, or does it bounce? And why?
I don't know how to tell.
Because it passes, it can't touch the vertical.
Well, I don't care. It can go down from there or up from there and still never touch the vertical asymptote. Right? I mean, think about it. It could go up and get closer and closer to that asymptote, or it could come up and still get closer and closer to the asymptote. Okay? But we're thinking,
Anyone online got a clue?
oh, the answer is already on the board as to why this can't, as to what's gonna happen.
So it can't.
Is it instead of positive numbers?
Huh?
Is it instead of positive two?
No,
Because.
Wait, because
there's only two x-intercepts. Right?
Wait.
So if this, we found the x-intercepts right here.
Oh.
Okay. So if it was to bounce and have to go back down, doesn't there have to be a third x-intercept?
yes.
There's a problem. It can't. Right? So it's gotta go through. And guys, that's just kind of putting some thought into what's going on. Right? Will this graph anywhere else touch the horizontal asymptote?
No.
No. Why? We found the one value where it touches. That's it. There's only one. Could there be more than one? Yeah, there could be. Does this one have more than one?
No.
Okay. Plot selected points as necessary. Okay. Guys, there is no right or wrong method of choosing these x values. You can plug any x value you want in, except -4, right? You can plug any x value you want in plot one. Okay. So we have broken the x-axis into 4 pieces. Did y'all see that? Anywhere there is a vertical asymptote or an x-intercept, that breaks the x-axis up. So I need to plot some points less than -4. So to do that, what you're gonna wanna do is actually, type that into your calculator and go to the table. Unless you're one of those people that just really enjoys to do the math and wanna plug them in and calculate it manually over and over and over and over again, okay? So, go to your y equals, type that in. Okay, and then go to your table and go to F negative. Don't go to the graph, don't cheat. You need to be able to think through these things.
Oh wait, I forgot how to plus.
It's best if you make this into a fraction when you're doing the y equals, right? Do your alpha y equals and have a numerator and denominator. Go to your table and tell me what f of negative 5 is.
I got 84.
84? Okay,
No,
so here's what we know. We know that this graph at negative 5 is way up there at 84, which tells us this graph is going to actually be trapped in this section. Does that make sense? Because it can't go below that, and it can't go past that. Okay? So we can't plot negative 5. How about negative 8?
Eighths.
105
I'm not
eighths.
sure I have the right thing typed in.
Okay. Well, that's more than 10, so I can't plot that point. Let's do f of negative 9.
It's 264 over 25.
264 over 20. Well, that's more than 10 also, isn't it? A little bit. It's like 10.3, I think. 10.5, I don't know, 10 point something. Okay, so at negative 9, we're up here. How about at negative 10? Okay. Which means the only part of this graph that I can actually see is going to be this little bitty curve piece right here. But can you envision that if this were extended forever and ever and ever, it's going down and it's getting closer and closer to the horizontal asymptote? Can you also see that it's going up? And as it gets closer and closer to negative 4, that graph is in fact approaching the vertical asymptote at negative 4. Okay, so now we know what's going over from negative 4 to negative infinity. Where are we between negative 4 and negative 3? I'm sorry, negative 4 and negative 2. So between negative 4 and negative 2, negative 4 and negative 2, we have negative 3. So what is f of negative 3? Oh my goodness. Okay. Which means this graph is super, super steep here. It's going to go off of the graph before it hits a negative 3. And it's coming down. I've got a couple points here in a row. It's coming down. It flattens out. Can you give me a value of f of 1?
0. Oh, wait, no, that's negative. Negative 6 over 20.
Negative 6 over what?
25.
Okay. So a little bit below. So it's coming up. It's coming up. And how about f of 3?
12 over 49.
12 over 49?
Yes.
Okay, so man, it's moving slow. Let's go ahead and go all the way in. Go f of 10.
66 over 49.
66 over 49. Is that about 1.5? I mean, type it in your calculator and see what it is. About 1.5 maybe? So at 10, we're up to 1.5. What is this graph doing here? It's invisible. That's what it's doing.
Slowly increasing.
So what happens is that horizontal asymptote is going to control the end behavior of the graph. In the negative world, that graph is going to decrease as it approaches negative infinity getting closer and closer and closer to -3. On the right side, as we get closer and closer and closer to x equal 50, that graph is increasing and it's going to get closer and closer and closer to the line, to the y value of 3. How does that graph look compared to what the calculator shows? If you press graph now, how does my graph look to what your calculator shows? Pretty fair? Okay.
Yours is a little sharp where it turns.
Yeah.
Sorry.
Questions on this?
Scrooge.
Okay.
How did you get in the camera?
I feel like this.
Do it alpha y equals.
You put that as a reflection.
Go y equals first. And go alpha y equals. Enter. Put the numerator and denominator. Okay. All right, let me go ahead and zoom out here. Screenshot, there you go, guys. Okay.
Yeah,
Okay.
sorry. Really not it.
Did you catch it?
I'm about to put you out of it.
Yeah, that's stand up.
You have a very drowsy voice.
I don't get drowsy during this class, and I try to sleep next class, and I have too
That's
much
because I
energy.
have such a pleasing voice.
No, you just have a monotone voice, and
It's
it's
so
so
pleasant.
boring.
You're so bored.
No offense, but actually,
You're
no,
so
I'm not.
boring.
Very.
All right.
No one said math was interesting.
Do you remember when we were doing polynomials? We talked about up, and down, and up, down, and all that stuff.
Yeah.
When it was even, they went together. They were either both up or both down.
Yeah.
Well, the same is true here, except now we're talking about when a graph approaches a vertical asymptote. When a graph is approaching a vertical asymptote, and we've got some even stuff going on, they're either going to increase forever on both sides or decrease forever on both sides if it's even. And if it's odd, it's going to do different things. So that's pretty wordy. All right, next slide.
What are you telling me to write? But you just zoomed. How am I supposed to write that?
Graphing a rational function with an oblique asymptote.
White line.
Okay. Does this have a horizontal asymptote?
Yes.
No.
it does not.
No.
It doesn't.
When the top is bigger than the bottom, there is no horizontal asymptote. There's only a horizontal asymptote if the degrees are the same or if the bottom is bigger. Because the top is bigger, there's no horizontal. But from notes the other day, we said that if the numerator is 1 degree larger than the denominator, then there's an oblique. Do we have a difference of 1?
Yes.
Yes. So we have an oblique asymptote.
Wait, what happens if the bottom's smaller again? It's y equals 0? No, it's not.
If the bottom's
Oh,
bigger.
Yeah,
If the bottom's bigger, it's y equals 0.
okay. I got
Next year, you should suggest your students to get
Do what?
laughing paper for these.
Well, you can go buy some. Yours not over.
I'm pretty sure you did suggest it.
he
though.
did.
No, we didn't.
Yeah,
On
because
his-
my
on
mom
his
told me to get
syllabus-
some and I said I didn't need any.
On his syllabus, it said graphing paper.
Okay, well, that was at the beginning of the year. I don't remember that. And we didn't do graph at the beginning of the year, so what was the point?
To prepare for the.
Okay, so to find that oblique asymptote, we have to do long division. So this fraction is the same thing as x squared plus 1 divided by x minus 2. and we're going to throw away the remainder if there is one. And there's going to be one. X times what is x squared? X.
Oh, I did it.
X times x minus 2. So we have x times x, which is x squared. And then x
Minus
times
2x.
-2 minus 2x. Now what?
Now, we change the signs.
Okay? Change the signs, combine like terms. X squared's gone. What's left?
It is
Plus 1.
2x plus 1. Does x go into 2x?
Yes.
yes.
How many
Two
times?
2 times.
Plus 2
Plus
times, right?
2 times.
Now we multiply. 2 times x is 2x. And 2 times -2 is -4.
Oh, wait.
So you, do you still change them?
Change the
2.
signs.
And throw away the.
So it'll be 5.
You write really fast.
Does x go into 5?
No.
Therefore, 5 is the remainder. I throw it away. What is the equation of the oblique asymptote? No.
I don't know. That's why.
Y equals x plus 2.
Sorry.
Y equals x plus 2 is the equation of the oblique asymptote. Okay? That has a y-intercept at 2 with a slope of 1. That is my oblique asymptote. Do we have any vertical asymptotes?
X equals 2.
At x equals 2, perfect. Because the value of x equals 2 makes the denominator 0, that's a problem. So x equals 2 is a vertical asymptote.
You write too fast.
It's not even writing. Zip it.
Squiggles.
No, you write too fast. Or you're in the way.
Now look at your computer.
It's dead.
There's a plug-in.
I don't know where my charger is.
Oh.
I have the
Keep writing
I'm just
slow.
kidding. I have the charger. It's in my backpack, but I don't have the
Oh,
effort to
I
get
see
out.
what you're doing.
Oh, actually, wait, we only have 2 minutes. Hold on, I decided not to.
What is she doing?
She doesn't want to get it out, so she's just not gonna.
She's just being lazy.
I don't want to get out.
Typical Hannah. Read.
No.
Typical Hannah, read.
Oh.
Will this graph ever touch the oblique asymptote?
Yeah.
No.
I don't know.
Okay.
Are you saying that so I can keep
Don't listen to me.
I have no clue what we're doing, so.
Will the graph touch the non-vertical?
All these lines look the same to me.
Okay, to find that out, you take the original function itself, which was x squared plus 1 over x minus 2, and set that equal to the non-vertical asymptote, which was x plus 2.
Oh, no.
Let's be. Wait, I thought you said something about oblique.
That is the oblique. Oblique is non-vertical.
I'm
This is
We should
vertical.
stick with one name.
Okay. A graph will never touch a vertical asymptote.
Okay.
A graph can touch a non-vertical asymptote.
So.
A non-vertical asymptote could be horizontal, or it could be not horizontal. And so instead of talking about horizontal or non-horizontal, we just say non-vertical.
So what's the point of a non-vertical asymptote if the graph can touch it?
You see?
It's the end behavior, just like the graph we did a moment ago. Okay? This graph here, The horizontal asymptote controlled the end behavior. This graph, as it goes to positive infinity, is getting
It
very
can't get
close to the
past it.
asymptote. As we go to negative infinity, this graph is coming down, approaching the horizontal. The horizontal or oblique asymptote only control the end behavior of the graph. And that's why it can't touch or go through. Okay? Okay.
Wait, but we don't have one yet.
So, the non-vertical asymptote was x plus 2. Can the function equal x plus 2? Make it look like a proportion. Cross multiply, so we get x squared plus 1 times 1 is x squared plus 1. And then we have x minus 2 times x plus 2.
Or
X squared
minus 2.
minus 2.
I'm gonna go with minus 4 if it's okay.
4.
Okay, because the OI cancels, right?
Wait.
We have a negative 2x and a positive 2x that cancel. Subtract x squared from both sides, and we get 1 equals negative 4.
I think that's pretty equal.
Okay, 1 equals negative 4 is not a true statement.
What? Kenna, get me out of this class. Is it for me?
Jeez.
There's no more fun class. Kenna's falling asleep. Ah. Is it for me? My shoes keep squeaking. Why not go to
Okay,
I heard it.
how do y'all feel about 1 equals negative 4?
Makes so much more sense.
Okay, totally false.
That is not true, so there's not one.
So will the graph touch that oblique asymptote?
No.
No.
Yes.
Well, you were. I was just.
We were right.
Y-intercept. What is f of 0?
No. Oh,
The y-intercept will be 0 plus 1.
it's 1
Okay, so
over
it'll be one.
negative 2.
So
It's
negative.
negative 1.
Okay,
What just happened?
right there.
Yes.
I just caught myself saying something.
Can y'all see that that part of the graph is going to be trapped?
Yes.
Yeah.
This graph is going to be trapped between these asymptotes because we've determined that it can't touch the oblique because we got a false statement, and it can never touch a vertical. So this graph is trapped down here somehow. Do we have any x-intercepts?
No, I don't think that can be.
How do you find x-intercepts?
You make the top equal 0.
Make the top equal 0.
That's the only.
Tell me. When will x squared plus 1 be 0?
You get
Never.
Why?
Because it's squared.
Yeah, you
Because
can't
x
square
is squared.
0.
Okay, the smallest that x squared could be would be 0, right? The 0 squared.
You can't square it.
And if you add 1 to 0, you get, how are we gonna get 0?
You can't.
Okay, this will never happen.
No. Oh.
What does that say? Carrot?
Cannot.
Your wrist is really affecting you.
So,
On these other hand, it's gonna be so bad.
guys, now we can just plot points. I need to, well, let me ask you this. Will the graph ever be up in this area?
No,
Why not?
Because
because it can't pass
Because
that
it's trapped down
line.
here, right? So this part, this value of negative 2 does not break the x-axis. The only break on the x-axis for this problem is at positive 2 where the vertical asymptote is. I just need some values. I need to figure out what maybe f of 1 is.
Negative 1.
I don't care about negative 1. Let's get further away. Let's go to negative 10.
Wow.
Because if I can get f of positive 1, which is over here, and f of 10 is over here, it'll kind of give me an idea of what's going on exactly here.
The negative 10 is negative 101 over 12.
Negative 101 over 12?
And 1 is negative 2.
Negative 101 over 12, about 8.4, negative 8.4. Okay, so at negative 10, I'm at negative 8.4, so about right here.
And 1
Uh-huh.
is -2.
So 1, I'm at -2. Okay, this graph is coming up and then it's going down.
But never touch.
How about, let's go a number greater than 2. Let's try f of 3.
F of 3 is 10.
Can you see where that graph is now trapped?
It's-
This
oh,
graph
it's
is now
the
gonna stay up in
opposite
this top
side.
triangle area, isn't it? Okay, so give me f of 4.
F of 4 is 17/2.
So there's two different parts of the graph?
Yes,
Oh, nifty.
so 8.5. So it's something like this.
All done then?
Okay,
All done.
all right, we'll stop there.
No, there's more.
We've got more.
So long.
We will wrap it up tomorrow.
You said that yesterday.
It wasn't
I wasn't here yesterday.
Where do you put it?
Oh, yeah.
Sorry.